Welcome to my series on being an applied statistician. In this particular video, we're going to be dealing with the One Way ANOVA in JAMOVI. So let's start where we always start, with our statistical test decision tree. And in this particular case, we're going to deal with another test of difference. So we're under here, under test of difference. So if your research question or your design study is one of difference, you want to be looking over here. The One Way ANOVA is an interval data test or a continuous data test, and the assumption is that the data is normally distributed. Now, we've already dealt with a two groups independent t-test, but what happens if you don't have two groups to compare, but rather three groups? You could do multiple independent t-tests, but as a basic principle, the more tests you do, the more possibility there is that you're going to make a mistake. There's going to be an error in the outcome. Therefore, it's always better to do one test as opposed to multiple tests. For this reason, we have the three groups, or more than three groups, One Way ANOVA. So if you have more than two groups, this is the test that you are going to be using. So now let's explain what we actually mean when we talk about this particular test. So let's look at the following research question. Is there a difference in the level of anxiety students have about writing in a meaningful literacy class, a 101 basic writing class, and a 202 research writing class? So we've seen anxiety questions in previous videos. But the difference here is, instead of just comparing two classes, let's say a meaningful literacy and a 101, in this particular case, we're comparing three classes: a meaningful literacy class, a 101, and a 202. So let's enter into some question analysis as we've done in the past. Do we have a grouping variable? Yes, we definitely do. It's called class type, and I have three classes: meaningful literacy, 101, 202. How many groups do I have? Well, in this case, I have three. If I only had two, I would do an independent t-test, but I have three groups. I'm comparing three classes, and therefore I need a different type of test. Are the groups independent? In other words, do I have different students giving me measures in each of the different classes? In this case, the answer is yes. If the answer was no, I would have to use a different type of repeated measures test. Do I have an outcome variable? Yes, I do. It's anxiety, and I have a 5-point scale. 1 high anxiety, 5 equals low anxiety. What type of variable data type is this? It's a continuous data. So what do we need? We need a test that compares three groups of students with one outcome variable. So here we have a schematic drawing of the One Way ANOVA. So let's go over this a little bit together in a non-technical way. So the first thing is we have three groups, right? We have group 1, 2, and 3. So for instance, meaningful literacy, 101 and 202. All three groups and the participants in all three groups do one measure. In our case, that's anxiety. I then have a situation where I have results for group 1, results for group 2, and results for group 3. Now, the ANOVA takes place in two stages. First, there is an actual test, the actual ANOVA test. And basically what I'm testing is whether these 1, 2, and 3 groups come from the same distribution or not. The idea here is, if they come from the same distribution, then they are the same. If they come from different distributions, then they are not the same. If this test is significant, we can then go on to do what's called post hoc tests, stage 2, where we basically compare the means between group 1 and group 2 and group 3, and group 3 and group 1. This is basically a modified t-test to just look at the group, to situate exactly where the differences are. When can you use the One Way ANOVA? Well, there's a few things here. When you want to compare the mean of 3 or more groups of participants on the same measure to see if they are really different, actually you're comparing variances, but we won't go into the technicalities of that in this video. 2, the test assumes that the groups are independent. You have different participants in each group. This is the same as the assumption for the independent t-test. The one-way ANOVA is a test for a single grouping variable and a single outcome measure. That's why it's called a one-way. In other words, one grouping variable and one outcome measure. And of course, the test assumes that the data is normally distributed. And with that, we're going to go over to the JAMOVI program and look at the one-way ANOVA in JAMOVI. As you can see, I've opened the JAMOVI program, and this is the beginning page. I've already opened the data set here. And let's quickly look at this data set, and then I'll show you how to do the one-way ANOVA. So this is basically the data set which answers the question we posed at the beginning of this video. So we have two variables here. One variable is called class type. Let me just double click on that, and that opens up this dialog box. As we can see, the variable is class type. What writing class is the student currently studying in? We have 3 levels for this: a meaningful literacy class, a 101 class, and a 202 class. And this variable is a nominal or a naming variable, grouping variable, because it's just the numbers standing for the names of the course. And I also have a anxiety measure. Let me just open that up. The level of self-reported anxiety that the student has about writing, 1 equals high and 5 equals low. And this is a continuous variable. Okay, so now let's do the test itself. So I'm going to go to ANOVA, and under ANOVA I find the one-way ANOVA. So I'm going to put class type, because that's my grouping variable, into the grouping variable, and anxiety into the dependent variables. And as you can see, I have one dependent variable and one grouping variable. That's why it's a one-way ANOVA. So the first thing I'm going to do is I'm going to test for normality, because if this is not normally distributed, then I probably don't want to do this. So in this case, I'm looking at the Shapiro-Wilk. The p-value is 0.015. As I've said in previous videos, if this p-value is above 0.001, then I'm going to consider it normally distributed. And in this case, I'm going to assume it's normally distributed. The next thing I want to do is look at descriptives. So I'm going to look at the descriptives table, and I'm also going to get descriptive plots. So let me start actually down here with the plots, and you can see that we're plotting out the 3 classes: the meaningful literacy, the 101, the 202. This is the mean, and we can see that the meaningful literacy and the 202 are way above the 101. So I'm going to look at the means in just 1 second, but it seems like the 101 class is very different in relation to the level of anxiety than the meaningful literacy or the 202. Remember that the higher you are, the lower on the anxiety scale, the lower the level of your anxiety. The lower you are, the higher the level of your anxiety. So let's actually look at the group descriptives. So the meaningful literacy, the mean is 3.5. So that's above the center point, so relatively low levels of stress. For 101, it's 1.8. That's closer to the 1 level. So I would say relatively high levels of stress. And for 202, it's 3.6. So even higher than meaningful literacy. So even lower levels of stress. So now we can look at the test itself. So remember, we do this in 2 stages. We're going to use Welch's F test, which doesn't assume equal variances, and we can find it up over here. This is the Welch's F, the degrees of freedom, 1 and 2. And here's what's important for us at the moment is the significance level. This is highly, highly significant, right? It's way below 0.05. So what does this mean? It means that there is a difference between Meaningful Literacy 101 and 202, that these do not come from the same distribution. That's good and that's very helpful, but that doesn't end the analysis, because what we would like to know is where the difference actually is. Is there a difference between Meaningful Literacy and 101, Meaningful Literacy and 202, or difference between 101 and 202? In other words, we need to situate where the difference is. To do that, we go over here to the post hoc. We're going to use the Games-Howell unequal variances because we use the Welch's F. Let me just click on that. And I also want the test results, the t-test and the DF levels, and I also want them to flag if something is different. So let's go down here to what's called the post hoc test. Post hoc meaning an analysis done after the main analysis. Just by the way, if we would have found the one-way ANOVA was not significant, you would not go on and do the post hoc test. But because it is different, we are going to look at it. So let's look at this. So meaningful literacy is compared to 101. Okay, and we see that it's flagged, and this is a significant difference, p-value of p.001. In other words, meaningful literacy is different from 101. However, meaningful literacy is not different from 202, right? So there's no difference between the meaningful literacy and the 202, but there is a significant difference between the meaningful literacy and the 101. In relation to the 101-202 comparison, 101 is significantly different from 202. So if we summarize these results, we would say the following. There is a significant difference in the level of anxiety between the three groups, as we can see in the Welch's F one-way ANOVA. When we consider where that difference is, the difference is that the 101 group has significantly higher levels of anxiety than either the meaningful literacy group or the 202 writing group. Now the only thing left to do is to write up our results and report them in the appropriate manner. And the final thing to do is to report the one-way ANOVA, and this is the language that is usually used. In order to test the difference between the three groups, a Welch's adjusted F ratio one-way ANOVA was calculated. A significant difference between the groups was found. Welch's F, the degrees of freedom, the F statistic, and then you give the p-value. We can see this is significant. And since this is significant, we're also going to report the post hoc tests. And here we have the language for the post hoc tests. Post hoc tests using the Games-Howell procedure revealed that the 101 class, and then you give the mean and the standard deviation, was significantly different from both the meaningful literacy class and the 202 class. Following this presentation and reporting, you then go on to explain the results in words. And in words, what I would say about this particular study is that the 101 class is the place where we have the highest levels of writing anxiety for students, and perhaps that's something that needs an intervention. And with that, we're finished with this particular video. I hope this has been helpful for you. I hope this helps you to do the studies that you want to do and the research you want to do. And I'll see you in our next video.